All right, so our last journal, I do not know where I put that. Okay. Our last journal is for lesson 2.3, and it kind of looks like this as well. So solve systems of equations by elimination. So I'm going to do the same thing. I'm going to flip it over, and I'm going to take it and try to fold it in towards the middle, kind of like, I don't know, I keep wanting to say a clamshell, but I don't know if that works right. I don't know if I'm saying that right. But anyway, so this one actually turned out a little bit better, but that's only because I messed up on the first one, and so I adjusted the spacing on the second one. So we're going to solve systems of equations by elimination. So when you glue this into your journal, you're actually gluing on, you're going to put glue on the back, and then you're just going to stick this in your journal. And that'll give you plenty of room up top for your I can statement. So remember, this is journal entry 4.3. Okay. So we're going to solve systems of equations by elimination. Well, what does this do? It eliminates one variable by using addition and subtraction. So we line up the variables. And the easiest way to do this is to make sure your equation is in, I hope you remember it, it's called standard form. Does anyone remember what standard form is? I know you're thinking. Standard form, capital A, X plus capital B, Y equals C. Remember, standard form, A, B, and C are integers, no, not fractions, okay? Find one variable that has an opposite coefficient of the other, and you're going to add or subtract to eliminate. They're going to solve for that variable and sub and solve for the other. Remember to write your solution as an ordered pair. Okay, write your solution as an ordered pair. So we have 3 examples here. Definitely going to have to rethink this one because I don't know if I can write this tiny, but I'm going to really try. So I'm going to look at this. Notice that this is written in standard form. And we're trying to find 2 coefficients that are opposite of each other. So when I look at my y term, I have a negative y and a positive y. So these are already stacked up. I'm just going to add these 2 equations together. 1x plus 2x, well, that's 3x. Negative y plus positive y, well, that's no y's. Y's go away. 11 plus 19 is 30. Divide both sides by 3. X equals 10. Yes, it really is just that easy. Let's now sub. So we're going to sub x equals 10. And I'm going to put it into the first equation. So the first equation, x minus y equals 11. But we know that x is 10. So 10 minus some value equals 11. Well, when I subtract my 10 from both sides, negative y equals 1. Divide both sides by a negative 1. Y equals negative 1. So my solution is the ordered pair 10, comma, negative 1. 10, comma, negative 1. I'm going to try and squeeze my check in here. So x plus, oh, sorry, it's x minus y. Stink, stink, stink. X minus y. I'm looking for some whiteout in this fabulous mess up here. X minus y equals 11. X is 10, so 10 minus y is negative 1 equals 11. Remember, when I have minus a negative turns that into a plus. So that gives me 10 plus 1 equals 11, and 11 does in fact equal 11. So that one works. Now let's try the second equation, my second equation. So I'm going to do the check for the second one. I have 2x plus y equals 19. 2 times x, which is 10, plus y, which is negative 1, equals 19. Well, 2 times 10 is 20. 20 minus 1 is, in fact, 19. Okay. All right, we're going to do it again. So in our next example, example number 2, I noticed that I have 2 of the same coefficients. My y's are both negative 9s. So let's see. What is something that I could multiply one of these equations by to give me a positive 9? So here's how I do this. I'm going to take the first equation and just leave it as is, meaning I'm going to multiply it by 1. I'm going to take the second equation and multiply it by a negative 1. So even though I'm not changing the first equation, I say that I'm multiplying by 1. So let's see. The first equation doesn't change. Negative 2x minus 9y equals negative 25. Second equation, every single term is getting multiplied by negative 1. Negative 1 times negative 4 is positive 4. Negative 1 times negative 9, positive 9. Negative 1 times negative 23, positive 23. So now I'm going to add these two terms together. Negative 2 and a positive 4 gives me 2x. Negative 9, positive 9 cancel out. Negative 25, positive 23 gives me negative 2. X equals negative 1. All right, I know x equals negative 1, so I'm going to take that and I'm going to sub it into the first equation. Negative 2x minus 9y equals negative 25. Be very careful when you substitute in for a negative. Remember to put that in a parenthesis. Negative 2 times x, which is negative 1, minus 9y equals negative 25. A negative times a negative is a positive. Minus 9y equals negative 25. Subtract 2 from both sides. Negative 9y equals negative 27. Divide both sides by negative 9, and I find out that y equals 3. So my solution is the ordered pair negative 1, comma 3. That's my solution, but I'm not done yet. I have to do the check. I've got to do the check. So I'm going to check equation number 1. So negative 2x minus 9y equals negative 25. So negative 2 times x, which is negative 1, minus 9 times y, which is 3, equals negative 25. A negative times a negative is a positive, positive 2. Negative 9 times 3 minus 27 equals negative 25. Positive 2 and negative 27 is in fact negative 25. So negative 25 equals negative 25. That checks good. Let's look at our second equation. Negative 4x minus 9y equals negative 23. Notice that when I do the checks, I always substitute my values into the original two equations. The original equations, okay? Negative 4 times, well, x is negative 1, minus 9 times y is 3, equals negative 23. All right, a negative times a negative is a positive. That gives me a positive 4 minus 27 equals negative 23. Well, 4 minus 27 is negative 23, and negative 23 equals negative 23. Whew. Okay, last one. We're doing great. So when I look at this last example, I have two coefficients, a 3x and a 5x. They're not even close to being the same as each other, not a positive or a negative. And then I have a negative 2 and a positive 5. So you have to make a decision. Do you want to get rid of your x's or your y's? So I try to always get rid of my y's first. I don't know why, that's just how my brain works. So if I multiply this first equation by a positive 5, that'll give me a negative 10 here. So if I multiply the second equation by a negative 2, that'll make my y term a positive 10. Notice that I'm just multiplying this first equation by the coefficient of the second and vice versa. All right, so 5 times 3, that's 15, 15x. 5 times negative 2, that's negative 10y, equals 5 times 2, which is a positive 10. Negative 2 times 5, that's negative 10x. Negative 2 times negative 5, well, that's a positive 10y, equals negative 2 times 10 is negative 20. Okay, 15 minus 10, that leaves me with 5x. Negative 10y, positive 10y cancel out, equals negative 10. Divide both sides by 5, and I find out that x equals negative 2. X equals negative 2. So now I'm going to take that and I'm going to plug it into either one of these original equations. I'm just going to put it into the first one. 3x minus 2y equals 2. 3 times x is negative 2 minus 2y equals 2. Negative 6 minus 2y equals 2. Add 6 to both sides. Negative 2y equals 8, which means y equals negative 4. So my solution, whoops, sorry, you couldn't see that. I'm going to pause for a second. So my solution is the ordered pair negative 2, negative 4. Am I done yet? No, I am not. I have to do the check. Remember that when I do the check, I plug these values into the original equations. So my first equation, 3x minus 2y equals 2. 3 times negative 2 minus 2 times negative 4 equals 2. Well, 3 times negative 2, that's negative 6. Negative 2 times negative 4, that's positive 8 equals 2. Negative 6 plus 8 is 2, and 2 does equal 2. So my first check, I didn't label that check, sorry. My first check is good. Let's look at my second check. Second check. I'm using the second equation, 5x minus 5y equals 10. 5x minus 5y equals 10. I'm going to substitute in a negative 2 for x, minus 5 times negative 4 for y equals 10. Well, 5 times negative 2 is negative 10. Negative 5 times negative 4 is positive 20 equals positive 10. Negative 10 and positive 20 is 10. 10 does equal 10, so it checks good. Whew. Okay. So this is your solving systems of equations by elimination journal 4.3. And you're going to glue this into your journal. And again, glue it into your journal right now. Don't stuff it into your backpack so you're looking for it in 3 days. Alrighty, that's it. Thank you.